In today's lecture, we will see how to solve the numerical problems related to the weir notches, and this lecture will consist for the evaluation of discharge over a rectangular as well as triangular as well as trapezoidal and a stepped notch, or you can say weir. So we will discuss the how to figure out the discharge for such kind of weirs. Then we will go for some example problem for the for understanding the effect of discharge over weir due to the error in the measurement of the head. So I mean, due to the error in the measurement of head, how it affects the evaluation of the discharge value for different weirs and notches. Then we will solve the some problems in which will evaluate the time required to empty a reservoir, or you can say tank, having a different shape of weirs, especially rectangular and triangular notch. Then we will solve some problem related to the velocity of approach that can be used for the different shape of weirs, especially rectangular, triangular and trapezoidal well as well. Further on, we will solve the problem using the empirical formulas for discharge over a weir. Using either by the two empirical formulas. First is your Francis formula, and second is your Bazin's formula. So these are the empirical formula that are used in the field for the estimation of discharge over a weir. Then we will take a numerical problem on the Cipolleti weir or notch. In this problem, I will also I will show you how to consider the velocity of approach for such kind of weir and or notches. For the estimation of Q, that is your discharge. And at the end of this lecture, we will solve some problems on discharge over a broadcasted and narrowcasted weir. And then at the end of this discussion, or you may say lecture, we will figure out the how to measure the discharge over a an oggy shape weir. Take a numerical problem to figure out the discharge of the water over a rectangular notch. So the problem says that find the discharge of the water flowing over a rectangular notch of 5-meter length when the constant head over the notch is 500 meter, and we have to take the CD value is equal to 0.6. So before starting the solution, we should first of all note down what the values which are given to us. So the length of notch that is given to us, that L is equal to 5 meter, and head over the notch or crest, or the crest of the notch is 500 mm, so that is 0.5 meter, and CD value is also given to us, that is 0.5, sorry, this is 0.6, 0.6. So the expression we will use to solve this problem is Q is equal to 2 by 3 CD multiplied by L multiplied by under root 2G H raised to the power 3 by 2. So this is 2 by 3, 0.6 multiplied by L is 5 multiplied by under root 2G, that is 9.81 multiplied by H is 0.5 raised to the power 3 by 2. So if we solve, this answer comes out to be 3.148 meter cube per second. That is the our answer. So the problem says that head of the water over a rectangular notch is 1800 mm, discharge is 1000 liters per second. Find the length of the notch when CD is equal to 0.6. So let's start for the solution. So the given values are H, that is 1.8 meter, and Q is 10,000 meter cube per second. Sorry, this is liter per second. So this value will be 10 meter cube per second. So here one important thing you can note down for your is that 1 cubic meter equals to 1000 liter. Now another thing that is given to us, that is CD, that is 0.6. So we have to determine the what is the length of the crest. So we will again use the same equation, that is Q is equal to 2 by 3 CD multiplied by L under root 2 G H raised to the power 3 by 2. So Q is your 10 multiplied by 2 by 3, CD is 0.6, L multiplied by 2, 9.81 multiplied by 1.8 raised to the power 3 by 2. So L is coming out to be 2.3255 meter. However, the preferable answers should be in the 2 digits, because this is the length of the crest. So you can write that this is 2.33 meters. So that is your answer. The length of the crest is this one. So you need to remember this thing. There are one variable, second variable, and the third variable. So out of three variables, two will be known to us, and third we have to derive. The only purpose for solving all the three types of problem which is shown over here is that if you keep on writing the formulas by your own self and just putting all the values 2 3 times, so it will be easy for you to remember the formula. So that's how you will not make any mistake while attempting any similar kind of problem in your examinations. Now we'll solve a numerical problem to find out the discharge over a triangular notch of angle 60 degree when the head over the V notch is 0.5 meter, by assuming that CD value is equal to 0.62. So let's start the solution. So the first thing that is given to us is the angle of notch is 60 degree, head is given to us, that is 0.5 meter, and CD value is 0.62. So the expression which we use for the triangular notch is Q is equal to 8 by 15 CD multiplied by tan theta by 2 multiplied by under root 2 G, then H raised to the power 5 by 2. So let's quickly put all the values. So 8 by 15 multiplied by 0.62, then tan 60 by 2 is tan 30, and degrees, you remember this point, and then under root 2 multiplied by 9.81 multiplied by H is 0.5, and that is raised by power of 5 by 2. So if we calculate this problem, this answer is coming out to be Q is equal to 0.1494 meter per second. So that is our answer. Now let's take a problem which involves the discharge over the rectangular as well as the triangular weir in the same problem. So the problem says that water flows over a rectangular weir 2 meter wide at a depth of 300 mm and afterwards passes through a triangular right angle weir. So taking CD for the triangular and taking CD value for the rectangular and triangular weir as 0.60 and 0.58 respectively, find the depth of the rectangular weir. So the problem is such that this problem is like water is flowing through a channel, and first it is passing through the rectangular and then it is passing through the triangular notch, and in both cases the same amount of water will be flowing. So the determination is such that whatever the Q input is over there, that will be again the Q output from the V notch. So what exactly we have to do? We have to find out the values, the dimension of the rectangular weir, and based upon the dimension of rectangular weir we will determine the Q value, and then we will equate the same thing that we obtained from the triangular notch. So let's start solving this particular problem. So for the solution, the values are given as L, that L is equal to is 2 meter wide, and height that is 300 mm, that is 0.3 meter, and CD value for the rectangular notch is given as 0.60, and we are using a triangular right angle weir, so theta is equal to, that is 90 degree, and for this triangular weir the CD value, which is 0.58. so these are the values for the rectangular one and this is for the triangular one. So what we are assuming that the discharge over the rectangular weir that is known to us. So based upon this one we will figure out the value of Q. So that is Q by 3 CD multiplied by L multiplied by under root 2G multiplied by H raised to the power 3 by 2. So this is 2 by 3 and CD value is 0.60, L value is 2 multiplied by 2 multiplied by 9.81 multiplied by h is equal to 0.3 raised to the power 3 by 2. So this value of q, will get it as 0.5852 meter cube per second. So that is the discharge we have measured from the rectangular weir. The same discharge is passing over the triangular weir. So we will use the equation of the triangular weir, that is q is equal to 8 by 15 CD multiplied by tan theta by 2 multiplied by root 2g h raised to the power 5 by 2. So we are just going to put the all values, that is, so q value is 0.5852 is equal to 8 by 15. CD value is 0.58 multiplied by tan 45 degree, that is tan 90 by 2. So this value is V1 multiplied by 2 9.81 multiplied by h raised to the power 5 by 2. So this h value is unknown to us. So h raised to the power 5 by 2 is equal to 0.4271. So h is equal to 0.4271 raised to the power 2 by 5. So that is 0.711 meter. So that is our answer. If the discharge is first of all passing through the triangular weir and then passing out to the rectangular weir, we can take a similar problem. So let's go for the other problem that says that water flows through a triangular right angle weir first and then over a rectangular weir of 1.5 meter width. The discharge coefficient of triangular and rectangular weirs are 0.65 and 69 respectively. If the depth of water over the triangular weir is 0.4 meter, find the depth of water over the rectangular weir. So let's start the solution. So the solution for this problem, so first of all we will note down all the values that is given to us. What it says is that in here the rectangular weir h is 1.5 meter, and so the values given to us is for the rectangular weir L value is 1.5 meter and CD value, that is 0.69, and for the triangular case that theta value is given to us. So theta is 90 degree. So for the triangular one, theta is equal to 90 degree. And another thing is CD value for this one is given, which is the 0.65, and h is given, that is 0.4 meter. And in this case, what will be the h value that we have to determine. So let's start the problem. So first of all, here the scenario is such that first of all a triangular weir is there and the same discharge is passing through over it, and again it is going through a rectangular weir. So again the q discharge will go over there. So this is the quantity that we have to equate from the two different shape of the weirs. So figuring out this solution for this problem, that is q is equal to 8 by 15 multiplied by CD tan theta by 2 multiplied by under root 2g h raised to the power 5 by 2. So it is 8 by 15 multiplied by CD is 0.65, tan theta by 2 is 45 degree. I mean 90 by 2 is 45, tan 45 is 1, and then under root 2g, 9.81, and then h is given to us, that is 0.4 raised to the power 5 by 2. So this q value is coming out to be 0.1554 meter cube per second. Now this is the same discharge which we were talking about. Now for the rectangular case, this discharge value is given to us. So q is equal to 2 by 3 CD multiplied by L multiplied by under root 2 G multiplied by H raised to the power 3 by 2. Q value is 0.1554 is equal to 2 by 3, and CD is 0.69. L value is 1.5 meter multiplied by 2 into 9.81, and then h raised to the power 3 by 2. So h raised to the power 3 by 2 will be equal to 0.0508. So h is equal to 0.0508 raised to the power 2 by 3, that is coming out to be 0.137 meter. So the answer for our problem is h is equal to 0.137 meters. So let's take a very interesting problem where a rectangular channel which is 2 meter wide has a discharge of 2500 liters per second, which is measured by a right angle V notch weir. Find the position of the apex of notch from the bed of the channel if maximum depth of water is not exceeded by 2.5 meters. We have to take the CD value as 0.6 meter. So if we draw the sketch of the particular problem, where the channel which is shown is over here is a rectangular channel, in which a V-shaped or you can say triangular notch is established, and this notch is such that it is at the some height above the channel bed. So this is the channel bed, and let's say the value this is x, and above the x above the apex water is flowing, and let's say this height above the crest of the weir is h. So in the particular problem, the maximum depth of is not should be excited between the 2.5 meter, which says that. So we are starting the solution. So the statement which is written over there, it says that h plus x should be 2.5. If we figure out this particular thing, then everything is possible to resolve. However, the q value is given to us, and where we can relate the q value with the h. Once corresponding to q, you can get what h should be there, and then you just add the subtract the h value from the 2.5 meter. You will be able to figure out the x, that is the required from this particular question. So let's start with this one. So the channel width is given us rectangular channel width B is equal to 2 meter. So this channel is 2 meter wide, which is not required in the any place during the solution of this problem. So the rectangular channel is 2 meter wide. The next thing it says that it has a discharge of 2500 liters. So Q is equal to 25 liters per second. That means 2.5 meter cube per second. Find the position. So it is a right angle notch. So theta is equal to 90 degree, and CD value that is also given to us is 0.60. So we will figure out the discharge over the triangular notch, that is Q is equal to 8 by 15 multiplied by CD multiplied by under root 2G multiplied by tan theta by 2 multiplied by h raised to the power 5 by 2. So Q is 2.5 is equal to 8 by 15. CD is 0.6 multiplied by 2 into 9.81, and tan theta 2 by 2 will become to be equal to 1 because this theta is equal to 90 degree, and then h raised to the power 5 by 2. Another important thing that this particular value you will require many a times once you are solving the weir notch, and this value usually comes out to be 4.429. So for your ease you can have you can remember this value. So every time you need not to take the root of the 2 into multiplied by the 9.81. So the h raised to the power 5 by 2 will be equal to, that comes out to be 1.7637. So this value will give the h value is equal to, this value is coming out to be 1.2548 meters. So h is known to us. Now the value of the h plus x is given to us, that should be 2.5. So let's say this is equation 1 and this is the equation 2. So let's solving the problem from equation 1 and 2. So this is 1.25 plus we can write the exact value 1.2548 plus x, that should be 2.5. So x is 2.5 minus 1.2548, that is coming out to be 1.245 meter. This is the our answer, that this is the position of the apex of the notch from the bed of the channel. So in this numerical problem, we will find out the discharge through a trapezoidal notch. So the problem says that find the discharge through a trapezoidal notch which is 2 meter wide at the top and 0.45 meter at the bottom and is 40 centimeter in height. The head of the water on the notch is 15 centimeter and CD for the rectangular portion is 0.62 while the triangular portion is 0.60. So we are very much aware that any trapezoidal weir is combination of the rectangular weir as well as the triangular weir. So in order to figure out the dimensions of this particular trapezoidal notch, which is given as to us that this is the 2 meter wide at the top, so that means this is 2 meter wide. Now what it says that 0.45 meter at the bottom, so this is 0.45 meter and 40 centimeter in height, so this is 0.4 meter. The only thing is that this value is not given to us, this value, and so distance between these 2 points is not known to us. So first of all we have to figure out this value, and then by using this triangle we can figure out what will be the our theta by 2. Then we will be having a complete dimension of this particular trapezoidal weir. So let's find out. So let's zoom this figure. Now it is more clear to you. So first of all, we will be finding out the values. So this bottom is 0.45 meter. So this overall length is 2 meter. So this particular portion which is shown over there in between this one will be equal to the 2 meter plus, let's say this distance is no. So let's redraw this thing. It will be making more clear to you. So this scenario is such that this look like this one. Now this is 0.45, then again it is 0.45, and overall value is 2 meter. So let's say this value is non-known to us. This is x, so this will be also x. So 0.45 plus 2x is going to be equal to 2 meter. So x is 2 minus 0.45 divided by 2. So this value is coming out to be 0.775 meter. Now again, if we go for the determination of the theta by 2, so theta by 2, so this value is 0.4 meter. So this height is 0.4 meter. So now the problem is such that our x value is 0.775 and this is 0.4 meter. This is your theta by 2. So tan theta by 2 will be equal to 0.775 divided by 0.4. So theta by 2 will be equal to tan inverse of so this value is coming out to be 62.7 degrees. Now theta is now known to us. Then we will find out the discharge through the trapezoidal notch. So that value is Q is equal to 2 by 3 CD1. So CD1 is we are considering that this is the rectangular one. So the CD for rectangular portion is 0.62. So this is 0.62 multiplied by L. So L is this portion is L is 0.45 multiplied by under root 2g. Under root 2g value is coming out to be 4.4294 multiplied by h raised to the power 3 by 2. So your h is 0.4 meter. So 0.4 raised to the power 3 by 2 plus 8 by 15 multiplied by CD. So CD of the triangular portion is 0.6 multiplied by the tan theta by 2. So we have already figured out that tan theta by 2 is coming out to be this value. So we need not to put again the theta by 2 is equal to 62 point and then figure out. So this value is coming out to be 0.775 divided by 0.4 is coming out to be 1.9375. 1.9375 and then multiplied by the under root 2g. Under root 2g is again coming out to be 4.4294 multiplied by h raised to the power 5 by 2. Now so again h is your 0.4. So this is 0.4 raised to the power 5 by 2. So we have to just calculate the values. So we will be having the answer that will be equal to, so this calculation is giving out to be Q is equal to 0.4863 meter cube per second. That is the our answer of this particular question. So in the problem of the step notch, geometry of a step notch is shown over there, where three steps are there, 1, 2 and 3. The dimension of each step is shown over there, which is 40 centimeter wide, 80 centimeter wide and 120 centimeter wide. However, the height of the levels of the all rectangular notches is given. So the values which is given to us, I mean the problem which we have to solve is that we have to measure the what will be the discharge over this stepped notch. So let's start for the solution. So if we need to solve this one, L1 value is given to us, that is 0.4 meter. L2 is equal to 0.8 meter, and similarly L3 is given to us, that is 1.2 meter. However, in case of H1 value should be measured for the channel 1 from the top of this location. So the height between these two locations, or the you can say the height between these two locations is called as the H1, which will be summation of 15 centimeter plus 30 centimeter plus 50 centimeter. So that is going out to be 0.95 meter. So better we should write in the terms of the centimeter right now, and then we can write that H1 is equal to 0.95 meter. And similarly H2 will be measured from this location to this location. So this value is coming out to be 30 plus 50, that is H2 is equal to 0.8 meter. And similarly H3 is 50 centimeter, that is 0.5 meter. Now we will in order to find the discharge, that it will be the summation of all the Q1 Q2 plus Q3. So if we write the expression, so for the Q1 is equal to 2 by 3 CD1. For example, for this particular problem, the CD is considered as a constant value, which is 0.62 for all the channels. So without any confusion, we can write that 0.62 multiplied by the L1 multiplied by under root 2g multiplied by H1 raised to the power 3 by 2 minus H2 raised to the power 3 by 2. Now we'll put all the values. So this is 2 by 3, this is CD is 0.62 multiplied by L is 0.4 meter multiplied by under root 2 9.81 multiplied by H1 is known to us, which is 0.95 meter. So this is 0.95 raised to the power 3 by 2 minus H2 is 0.8. So 0.8 raised to the power 3 by 2. Now Q1 value, if we solve, this is coming out to be 0.154 meter cube per second. Similarly, for the determination of Q2, we can write that this is 2 by 3 into CD multiplied by the L2 multiplied by under root 2g, and in brackets H2 raised to the power 3 by 2 minus H3 raised to the power 3 by 2. If we'll put all the values, so 2 by 3 0.62, L2 is given to us, that is 0.8 meter, 0.8 meter multiplied by 2 multiplied by 9.81, and in brackets this is 0.8 raised to the power 3 by 2 minus 0.5 raised to the power 3 by 2. Now so Q2 will be, if we calculate, this value is coming out to be 0.530 meter cube per second. And similarly, in order to find the Q3 value, this value is coming out to be 2 by 3 CD multiplied by L3 multiplied by under root 2g, and here the subtraction is not required, so this is h3 raised to the power 3 by 2. So q3 is equal to 2 by 3 multiplied by 6 to L3 is 1.2 meter multiplied by under root 2 multiplied by 9.81 multiplied by S3 is your 50, so this is 0.5 raised to the power 3 by 2. So Q3 is coming out to be 0.776 meter cube per second. So if we figure out the what is the total discharge through this step channel, that is Q1 plus Q2 plus Q3. So if we just noted down the values of Q3, that is 0.776 plus Q2 is 0.530 plus Q1 is coming out to be 0.154, that is your Q. So the final Q discharge, that will be 1.460 meter cube per second. That is our answer. We work. So our next problem is based on the estimation of the error in the discharge due to the error in the measurement of the head. So the problem says that a rectangular notch which is 90 centimeter long is used for measuring a discharge of 120 liter per second. An error of 3 mm was made while measuring the head over the notch. So we have to calculate the percentage error in the discharge considering that CD is equal to 0.6. So if we start with the solution, so what exactly we find out that the L value on the length of the notch is given as 90 centimeter, that is 0.9 meters, and Q is given to us is 120 liters per second, that is 0.12 meter cube per second. And so the error in the head is, that is DH is 3 mm, that means 3 into 10 to the power minus 3 meters, and the CD value which is given to us is 0.6. So the first of all we will find out the what is the H. So Q is equal to 2 by 3 CD multiplied by L multiplied by root 2G H raised to the power 3 by 2. So Q is equal to 0.12 multiplied by 2 by 3. CD is 0.6, L value is 0.9, and under root 2 multiplied by 9.81 and H raised to the power 3 by 2. So from this equation we can figure out the value of the H, that will come out to be 0.178 meter. So we already have the DH. So for this we have already derived that dq over q will be 3 by 2 times of dh over h. This is valid for the rectangular notch, and when this problem is for the triangular notch, this 5 by 2 will be equal to 3 by 2 will be equal to 5 by 2. Now, so the dq over q will be 3 by 2 multiplied by dh. We have find out this dh value is 3 into 10 to the power minus 3 divided by h value is 0.178. So this is coming out to be 0.025. So if in percentage we can say that dq by q is equal to 2.5%. This is our answer. So let's again solve a problem which is similar to the our previous problem, where the instead of the rectangular weir we are going to use the V notch. The problem says that a right angle V notch is used for measuring a discharge of 120 liters per second. An error of 3 mm was made while measuring the head over the notch. Calculate the percentage error in the discharge when taking the CD value of 0.6. So let's go for the solution. So that comes out to be, so this is I mean right angle V naught, so theta is equal to 90 degree, and Q value is given to us, that is the 120 liter per second. That means 120 meter cube per second. The error while measuring the head over the notch is 3 mm. This is 3 multiplied by 10 to the power minus 3 meter, and CD value is 0.6. So similarly, let's assume that the head over the notch is H, that we have to determine. So the formula we use for the triangular notch is 8 by 15 CD multiplied by tan theta by 2 multiplied by under root 2g h raised to the power 5 by 2. So let's put all the values. 8 by 15 multiplied by 0.6 multiplied by tan theta by 2 will be 1, multiplied by 2, 9.81 multiplied by h raised to the power 5 by 2, and here it is 0.12. So h will be equal to 0.3724 meters. So now we are aware that how much dh is available. So similarly for the triangular notch, we can write that dq over q is equal to 5 by 2 times of dh over h. So that is 5 by 2 multiplied by dh is 3 mm, and here it is 0.3724. So this is 372.4 mm. So this value will come out to be 0.020. So in percentage, dq by q in percentage is 2.0. So let's take an interesting problem related to the error in the discharge due to the measurement of wrong value of the head. So the problem says that head of the water over a triangular notch of angle 60 degree is 100 centimeter and the coefficient of discharge is 0.6. The flow measured by it used to be within an accuracy of 3% up or down. That means 3% plus or minus. So find the limiting values of the head. So let's go for the solution of this particular problem. So theta value is given, that is your 60 degrees. H is your 100 centimeter, that is 0.1 meter, and CD is 0.6. So the error which we are allowed to occur in the measurement of discharge is 3%. So that is dq by q is equal to 3%. So we can write it as plus minus 0.03. So we are aware that for the triangular notch, q is equal to 8 by 15 CD multiplied by under root 2g tan theta by 2 h raised to the power 5 by 2. So if we put all the values, this is 8 by 15 multiplied by 0.6 under root 2 9.81 multiplied by tan theta by 2 will be tan 30 degree, and h value is given to us, that is 0.1. So 0.1 raised to the power 5 by 2. So if we calculate, the q value is coming out to be 2.5878 meter cube per second. That is the q value. we are already aware that dq over q for the triangular notch is 5 by 2 times of dh over h. So already we are aware that dq over q is allowed, that plus minus 0.03 is equal to 5 by 2 dh. Dh is dh that we have to determine. So dh divided by h is equal to 2.5878. So the dh is equal to 0.03 plus minus multiplied by 2 divided by 5 and then multiplied by 2.5878. This is 3.10 10 to the power minus 5. So dh is this much meter. So we can write it that in the terms of the centimeter. So this value will be 3.10 10 to the power minus 2 mm. Or we can say that it is 0.310 meter. That is the value of dh. So the allowable head, that will be equal to the allowable head will be equal to h plus minus dh. 0.1 meter, so 0.1 meter, then plus minus 0.0310. So this value will be coming out to be either, so this value is coming out to be either this value if we take the plus sign, or this value if we take the minus sign. So if you see, this particular value is coming out to be when we are considering the plus sign, and this value is coming out to be this side. So our answers are that 0.1310 meter and 0.069 meter. That is the limiting values of the head. For the maximum and minimum values of head. So let's solve one problem where we have to figure out the height of the weir, where the discharge and other details are given. So the problem says that determine the height of rectangular weir of length 8 meter and built across a rectangular channel. The maximum depth of water on the upstream side of weir is 2 meter and the discharge is 5000 liter per second, and we have to take the CD value as 0.6, and we have to we need not to consider any contraction in the weir. So for such kind of problem it will be very easy if we first of all draw the problem that will easy to understand to figure out the height of the crest and as well as the height of the water on the upstream, and then we can figure out the head, and then we can find out the value of the required thing by equating the equation of the q. So for the solution, so the values given to us is length, that is your 8 meter, and q value, that is our 5000 liter per second. So we can say this is the 5 cubic meter per second, and the CD value this is given to us is 0.6. So the value which is given to us is the maximum depth of water on the upstream side of weir. So let's say that this particular value is our h1, and this h1 is 2 meter. So we will draw the diagram for this kind of thing. So suppose weir is here, So this is the base, and over which a weir is such that now the water is flowing on the weir at this thing. Now the water goes like this way. So the given value to us is the height of upstream water above of this one. So this value is your h1. This value h1 is 2 meter, and the question which is asked for is the this value. So this is unknown. However, the Q value, that is the discharge which is passing through this weir, that is given to us. So we can relate this problem with the equation of the discharge, that is Q is equal to 2 by 3 CD multiplied by L under root 2G multiplied by H raised to the power 3 by 2. So let's say this is the H. That value we have to determine. This value is h. So let's quickly put all the problems. So Q value, that is our 5, is equal to 2 by 3 multiplied by 0.6 multiplied by L, that is 8, then multiplied by under root 2G. So this is 2 into 9.81 multiplied by H raised to the power 3 by 2. Now the in this particular equation only one unknown value is there and one equation there. So from just figuring out the what h value will be there, we can calculate it. So the h value which is coming out to be, so this comes out to be h raised to the power 3 by 2 is 0.351. So h is 351 raised to the power 2 by 3. So this value will be coming out to be 0.4975 meter. Now if we look at this figure which is given to us, and this value is h, this value is h1. So the weir length, I mean you can say weir height, which we have to determine is this value. Let's say this is h. Now if we look at the figure, we can quickly write is that h1 is equal to h plus h. Now h1 we already have, that is given in our equation, that is 2 meter, is equal to h that we have to determine, and the capital H we have just figured out, that is 0.4975. So the h value will be 2 minus 0.4975. So this value is coming out to be 1.502 meter. So that is the our answer, that height of the weir is 1.502 meter. Problem is related with the estimation of the time required for lowering the water level in a reservoir. So other way around, you can say that this is the estimation of time required to empty a reservoir or any tank with any triangular or rectangular weir. So we are taking the problem, that is find the time required to lower the water level from 5 meter to 3.5 meter in a reservoir of dimension 95 meter by 95 meter by a rectangular notch of the length 3.0 meter, and the CD value is given as 0.6. So the solution can be obtained by, so first of all, figuring out all the parameters which are given, that is the level of the water, the initial level of the water we are assuming that with the showing of the h1, and that is the 5 meter. So with some time the water level gets to a height of 3.5 meter, that is your h2. Now the dimension of the reservoir is 95 meter by 95 meter, and then we can say the area is coming out to be 95 multiplied by 95, that comes out to be 95 square, that is 9025 meter square. Now the length of the weir is given as 3 meter. So this is the weir length. Now another point which is given to us is CD is equal to 0.6. So we have to use the formula time required to empty reservoir with a rectangular notch. So that is time t can be find out by 3a divided by CD into L into under root 2g in brackets 1 by under root h2 minus 1 by under root h1. Now let's put all the values. So 3a is 9025 divided by CD value is 0.6 multiplied by length of the weir is 3 meter, then under root 2g, that is 9.81 multiplied by 1 over under root h2, that is under root 3.5 minus 1 under root 5. So let's solve this value. So this value comes out to be, so the calculation gives that this is 294.71 seconds. So that is the our answer, that this much time will required to reach the water level from a height of 5 meter to 3.5 meter using a rectangular weir of having this much size, and this is the CD. So our next problem is similar to the previous problem. So instead of a rectangular notch, a right angled V notch is being used, and we have to figure out the time required for the change in the level of water in the reservoir using the same data. So let's go for the solution of this problem. So all the data, because this is a right angle V notch, so theta is equal to 90 degree, and here h1 was 5 meter, h2 was 3.5 meter, and the area which was 95 multiplied by 95, that was 9025 meter square. I guess I'm right, yeah, 9025. And then the another thing that it's asked is that CD value is 0.60. So we will use all the data which is available over there in the formula for the time required to empty a reservoir with a triangular weir. So that is T is equal to, instead of 3a it will be 5a divided by 4 times of CD multiplied by tan theta by 2 multiplied by under root 2g, and then 1 over h2 raised to the power 3 by 2 minus 1 over h1 raised to the power 3 by 2. So let's put all the values over here. So T is equal to 5 multiplied by 9025 divided by 4 into CD value is 0.6 multiplied by tan theta by 2, that will be the tan 45, and tan 45 is 1, and under root 2 into 9.81 divided by 1 over this is 3.5 raised to the power 3 by 2. So we can write it as a 1.5 minus 1 over 5 raised to the power 1.5. So let's quickly solve this equation. So the calculation gives this value as 268.78 seconds. So this is our answer. So you can see the difference. The earlier answer was 294.71 seconds. However, this answer is 268.78 seconds. So let's take another problem. So that says that a right angle V notch is inserted in the side of tank of length 4 meter and width 2.5 meter. Initial height of water above the apex of the notch is 30 centimeter. Then it is asked that to find the height of the water above the apex if the time required to lower the head in the tank from 30 centimeter to final height is 3 minutes. We have to take the CD value as equal to 0.6. So before doing this problem, first of all, we need to understand what is being asked. So what exactly is the scenario is that the initial height in the channel is, in the weir is given to us, and after the 3 minutes it reaches to a new height of this one. So this value is known. Only this value is asked if it is given that this much time takes a 3 minute. So in the 3 minute, how much the lowering of the water level will be happen in the case of the V notch. So that's what we need to require. So this value is your H1 and this value is your H2. So in this equation, H2 is unknown, and however the H1 value is already given to us. Now once you are able to figure out the meaning of the question, that it's very easy for us to solve the question. Now again we will have to use the expression of the t, and all the other values are given to us, only this h2 is unknown, and we can quickly solve this problem. So the problem is such that theta is equal to 90 degree because right angle notch, and then area of the channel, that is a, is equal to 4 meter multiplied by 2.5 meter. That comes out to be 10 meter square. And initial height above the apex of the notch is, that is your h1, that is your 30 centimeter, that means it is 0.3 meter, and the time required for reaching a level of another final height, that is we are assuming that h2 is 3 minutes. So 3 minutes is equal to 180 seconds. That's all. So also the CD value is 0.6. So only we have to write the formula required to empty a tank using a triangular notch. That equation, that is T is equal to 5 multiplied by A divided by 4 CD tan theta by 2 multiplied by under root 2g, and in brackets 1 divided by h2, that is unknown to us. So h2 raised to the power 3 by 2 minus 1 divided by h1 raised to the power 3 by 2. Now you have to remember this thing, that h1 is already given to us, only this h2 we need to figure out. However, the time is also given to us. So let's quickly put all the values. So t is equal to 180 seconds, 5 multiplied by 9, this is your 10 divided by 4, CD is 0.6, tan theta by 2 will be 1, and multiplied by under root 2g. So under root 2g, if you count, this is coming out to be 4.4294 multiplied by 1 over h2 raised to the power 3 by 2 minus 1 over h1 is given to us, that is the 0.3 raised to the power 1.5. The only thing we have to solve this problem just in order to get the h2 value. So h2 will be, so after calculation this value is coming out to be 0.7, sorry, this is 0.0797 meter. So we can write it as a 7.97 centimeter. That is the our answer for this problem. That's all for this problem. So let's solve a problem which is based on the velocity of approach. So which says that the find a discharge over a rectangular weir. Please read it as a weir of length 120 meter, and the head of the water over the weir is 2 meter. The velocity of approach is given as 0.75 meter per second, and we have to take the CD value is equal to 0.6. So let's start solving this problem. So the solution of this problem can be find out using the consideration that length of the channel L is given to us, that is 120 meter, and the head over the weir, that is your our h1, is 2.0 meter, or you can simply write it as a h, that will be good one. And the velocity of approach, which is shown by the va, is 0.75 meter per second, and CD value is 0.6. So first of all, we will figure out what is the head induced by the velocity of approach. So HA is VA square divided by 2G. So VA is 0.75 square divided by 2 multiplied by 9.81. So this value comes out to be 0.0286 meter. Now once HA value is available to us, we can simply put the HA value in the expression of the discharge over a rectangular weir due to the velocity of approach, and that can be written as Q is equal to 2 by 3 CD multiplied by L multiplied by under root 2G, and in brackets this is H plus VA. Sorry, this is not VA, this is HA. HA raised to the power 3 by 2 minus HA raised to the power 3 by 2. Now we will put all the values, that is 2 by 3, CD is 0.6, L is 120 multiplied by under root 2, 9.81, and then H value is given to us, that is 2, plus HA is 0.0286 raised to the power 3 by 2 minus 0.0286 raised to the power 3 by 2 and bracket close. So let's quickly solve this problem. So the simplification of this values gives the Q value of 613.51 meter cube per second. So that is our answer. So the next problem is with the related with the suppressed rectangular weir, and where the velocity of the approach is will be considered for the estimation of the discharge. So the problem says that a suppressed rectangular weir is constructed across a channel of 0.9 meter width with a head of 0.45 meter, and the crest is 0.6 meter above the bed of the channel. So estimate the discharge over it considering the velocity of approach and CD value of 0.6. So let's go for the solution of this problem. So what it says that the channel is 0.9 meter wide, so this width of channel is 0.9 meter. However, the head, that is very important, because the head of the water over the weir, which is given as the 0.6, however, sorry, 0.45, and the crest is already 0.6 meter above the bed of the channel. So the depth of flow of the water, depth of flow of the water above the channel bed will be equal to the uh, height of the crest from the channel bed plus head of the water over the weir. So the from channel bed plus head of water over weir. So the depth we can say is coming out to be, so height of crest from the channel is given as the 0.6 meter and the head of the water is 0.45 meter. So this value is coming out to be 1.05 meter. So 1.05 meter is the depth of flow. So if in the pictorial format, if we say this is the crest and this is the, sorry, this is the weir and this is the channel bed, and now the water level is flowing like this way. So this crest from the bed of the channel, that is the uh, 0.6 meter, and another, this value is given as 0.45 meter, and then total height of flow will be coming out to be 1.05 meter. I guess this picture would have been made you more clear about the things I have just mentioned above. So using this concept, let's go for the solution. So the CD value which is given to us is 0.6. So CD value is 0.6, and there is a very special objective is written. In this particular problem, there is a very special adjective is written with the weir, that is the suppressed weir. Then the meaning of the suppressed weir is that whenever we are talking about any suppressed weir, that means there is no end contraction. So what we can say, that there is no end contractions. So in such cases, the whatever the width of the channel will be there, that will be the equal to the width of the weir. So we can say that width of the channel that is given to us, that b is equal to, we have already done, b is equal to 0.9 meter. So b is equal to 0.9 meter, and that will also be the width of our weir, because this is a suppressed channel. Now, so let's proceed. So the area of flow, we can figure out that area of flow will be equal to the depth of flow that is given to us. I mean, just we figured out the depth of flow is 1.05 meter and multiplied by the width of the weir, that is 0.9. So this value comes out to be 1.05 multiplied by 0.9. So the answer is 0.945 meter square. So this is the area that we will write, A is equal to 0.945 meter square. Once we do have this particular value, we should first of all figure out what the Q value will get from the rectangular weir, considering the formula without having the consideration of VA at the very first time. So Q value will be coming out to be 2 by 3 multiplied by CD, that is 0.6, multiplied by B, that is the width of the width of the weir, that is you can say that is also the L. So that is the width, or you can say length, So that is given to us is 0.9 and multiplied by under root 2g, that is 2.981, and multiplied by h raised to the power 3 by 2. So here the height, the flow, that is our, so this value is the head over the crest is that is 0.45 meter. So this value is 0.45 raised to the power 3 by 2. So if we solve this problem, q value will come out to be, so the simplification gives that q value is equal to 0.4837 meter cube per second. So remember that this particular q value is without the consideration of the velocity of approach. That's what we do in the very first iteration. So this was the our first iteration. Now we will proceed for another iteration. So the second iteration says that first of all we have to figure out the velocity of approach. Now the velocity of approach will be the discharge that is available to us and then divided by a. So discharge is 0.4837 divided by area. So a value is 0.945 and that value is coming out to be 0.5119 meter per second. So corresponding to this velocity, if we figure out the head, that is va square divided by 2g. So that value will be coming out to be, that's a square divided by 2. So we are using a value of g is equal to 9.81. So this answer is coming out to be 0.013 meter. So this is our HA. Now we will use this HA in the expression of Q. So then Q value will be 2 by 3 CD multiplied by length of the weir, that is also the width of the channel. You need to remember that L is equal to P because this is the suppressed weir. Now this value is under root 2g multiplied by in brackets h plus ha raised to the power 3 by 2 minus ha raised to the power 3 by 2. So all values are all available to us. Ha we just got it. H value we are aware that this h is 0.45. So this value is 0.45 and in HA we will put the value that is 0.013 and similarly here also 0.013 and L is that is L is our 0.9 and this value is 0.6. So after just putting all the values, the Q value is coming out to be, so the calculation gives Q value is equal to 0.5024 meter cube per second. So that is the Q value obtained after the second iteration. And the first iteration, this answer was 0.4837. You can see this thing. This is coming out to be 4837. However, this value is 0.5024. So there's a much difference. Then we have to go for the one more round for the iteration. So that is our third iteration. And the same thing we will follow. So in the third iteration, the Q value we obtained in the previous iteration will be our base for starting our problem. So then VA, that is the velocity of approach, will be Q by A. So A is not going to be changed. However, the Q value has been revised as a 5024 divided by A is 0.945. So this value is coming out to be 0.5316 meter per second, and corresponding to this value the HA value will be VA square by 2G. So square of this divided by 2 divided by 9.81. So the value is coming out to be 0.0144 meters. Now we will use this HA value for the estimation of the discharge. So that is Q is equal to 2 by 3 CD multiplied by width of, or the length, that is the B, or you can say L, multiplied by under root 2G, and in brackets head plus HA raised to the power 3 by 2 minus HA raised to the power 3 by 2. Now again this value is 0.6, this value is 0.9. This value, you always know that if you take the under root of 2G, this value is coming out to be 4.4294, and this H is 0.45, 0.45, and then HA value we are figuring out as a 0.144, and similarly here 0.144. So if we put all just this value is 0.0144, this is 0.0144. so you should be very careful while solving this problem, because a simple mistake of the decimal point will ruin your all the hard work. So if we find out the Q value, that comes out to be 0.5042 meter cube per second. So this is our Q value, what we are getting from the third iteration. So if you look at the findings from the first iteration, second and third iteration, so this is 5042 and this is 5024. So now the difference between these two values is very small. So if we just figure out that how much difference we are getting, so this is percentage error in the Q value, consecutive Q values is 0.5042 minus 0.5024 divided by 0.5024 divided by 0.5024. So this value is hardly equal to 0.37 percentage in percentage. So this is very close value. So we can say the answer we got over here is the correct one, and we can end up the iteration process, and we can assume that the whatever the Q value we find out is the perfect solution. So let's take another problem where a sharp crested weir is available there. However, in this one the end contraction effect is also considered along with the velocity of approach. So the problem says that water flows over a rectangular sharp crested weir which is 2 meter long, and the head of the water over the sill of the weir brings 0.8 meter, that is the head, and the approach channel is 1.5 meter width, and the depth of flow in the channel is 1.5 meter. Determine the area of discharge over the weir. Consider also the velocity of approach and an effect of the end contractions. Take the coefficient of discharge of the weir as a 0.6. So let's go for the solution of this one. So before starting the solution, we will write down all the given values. So the important thing is that this end contractions are available there. So if any rectangular channel is available there and end contractions are over there, so at the end there are two ends, so the end contraction will be 2. So this is 1 and this is 2. However, we usually denote the end contraction by a number of n. So here the number of contractions at the end, that is end contraction, that is 2, and length is given as the length of the weir is 2 meter. So we write L is equal to 2 meter. And another thing is that head of the water over the weir that is given to us, that is head of the water is 0.8 meter. So this value we just write with the letter H, that is 0.8 meter. Then width of the channel is given to us. So width of the channel, that we write with letter B. So B is given as 1.5 meter, and the depth of flow in the channel is 1.1 meter. So depth of flow in channel is 1.1 meter. 1.1 meter. Now, so first of all, we will determine the area of flow of channel. So this area of flow of channel is written with the letter A. Channel flow, that is A. So A is equal to depth of the channel multiplied by the width of the channel. So depth is 1.1 meter and the width of channel is 1.5 meter. So let's calculate this value. This comes out to be 1.65 meter square. CD value is already given over here, that is 0.6. Then we have to consider the velocity of approach and end of the end contraction. So the equation we will be using will look like the similar like this one, that Q is equal to 2 by 3 multiplied by CD multiplied by the under root 2G, and then the L minus 0.1 into N H plus HA, and then multiplied by H plus HA raised to the power 3 by 2, that will also be in bracket, minus HA raised to the power 3 by 2. Now there is important thing that this N shows the end number of end contraction. This value is 2. However, in the estimation of the Q value, in such situation, see, so HA value is very low. So in the very first estimation of the Q, we can assume that HA value is equal to 0, because the velocity of approach is also very low value. Corresponding to this, HA value is 0. So in the estimation of the discharge at very first time, we will be assuming that HA is equal to 0. So now we will put all the values, that is Q is equal to 2 by 3 multiplied by 0.6 under root 2G, that is 2 multiplied by 9.81 in bracket. L is given to us, that L is 2 meter. 2 meter minus 0.1 multiplied by 2, that is the number of in contraction, and multiplied by HA we are considering 0. So however, total capital H is 0.8, that is your head, and then the H, that is the 0.8 raised to the power 3 by 2. HA we have considered 0. So using this particular thing, we will estimate the Q value. That value will, so calculation gives that Q value is equal to 2.344 meter cube per second. So this is the Q value obtained from the first iteration. So we have to remember that in the very first iteration, we have to take the HA value that is equal to 0. We have to neglect this HA, and then we have to find out the Q. So we will go for the second iteration. That says that uh, first of all, determination of VA corresponding to Q divided by A. So Q is 2.344 divided by area of the channel is 1.65 meter square. So this comes out to be 1.42 meter per second. And then corresponding to this HA, VA value is VA square by 2G. So 1.42 square divided by 2 multiplied by 9.81. So square divided by 2 divided by 9.81. So this value is coming out to be 0.1028 meter. Now we will use this HA value for the estimation of Q. So Q is equal to now the 2 by 3 CD multiplied by under root 2G and then we'll use that in brackets L minus 0.2 because 0.1 into N and multiplied by H plus HA, S plus HA bracket close, and then HA plus H raised to the power 3 by 2 minus HA raised to the power 3 by 2. That value will give the Q value. So Q is coming out to be 2 by 3, CD is 0.6 and this value is 4.4294, and then L value is given to us, that is 2 minus 0.2 in brackets H is equal to 2 meter, 2 plus HA is 0.1028 bracket closed, and then this is 2 plus 0.1028 raised to the power 3 by 2 minus 0.1028 raised to the power 3 by 2 and then bracket close. So now we have to solve this expression that will be giving the Q value, and that is equal to, so after putting the all concerned value, the equation look like as after putting all the concerned values, the expression of Q will look like this one, and then figuring out the solving this equation will give the value of Q that is equal to 2.669 meter cube per second. So that is the Q value we obtained after the second iteration. So if we compare, the first iteration was giving the Q value is equal to 2.344 and the Q value is 2.669 in the second iteration. So however, this is big difference, so we should definitely go for the third iteration. So let's do the third iteration. So third iteration will give us, first of all, we will determine the velocity of approach. So VA is equal to Q divided by A. So Q is 2.669 divided by A is 1.65. So VA is coming out to be 1.617 meter per second. Corresponding to this VA, the HA value is VA square by 2G. So HA is coming out to be 0.133 meter, and then we will use this HA value for the estimation of Q. So this Q expression will be again the Q is equal to 2 by 3 CD, 2 by 3 CD multiplied by 2G, and then in bracket L minus 0.2, and in bracket H plus HA, the HA value we got over here, and then again H plus HA raised to the power 3 by 2 minus HA raised to the power 3 by 2. So now let's quickly put all the values. So this is 2 by 3 multiplied by 0.6, then multiplied by uh, under root 2g, is that will be coming out to be 4.4294, and then L value is 2 minus 0.2, H is 0.8, and then HA value is 0.133, bracket closed, and then H plus HA is 0.8 plus 133 raised to the power 3 by 2 minus 0.133 raised to the power 3 by 2, and then bracket close. So let's quickly solve this values. So the Q value is coming out to be 2.752 meter cube per second. This value is coming out to be after third iteration. So after third iteration, we can see that these values are very close. So if we figure out what is the percentage error, so percentage error in the consecutive Q values will be 2.752 minus 2.669 divided by 2.669. So in percentage, this value is coming out to be 2.669 divided by 2.669 and multiplied by 100. So this value is giving us a 3.1 percentage of error. So in the consecutive value, this error is very much appreciable. So this answer you can adopt, as a final answer. However, if you want to go for the further more precise answer, you can go for the fourth iteration. So that's how this such kind of problem should be solved when the end contraction is also involved along with the velocity of approach. So this is a very complicated problem. However, you can easily do it with the consideration of proper number of the end contraction as well as the determination of HA. So the HA is also involved in the while subtracting the contraction value, then you have to take care this particular thing. That is the additional one which is coming into the expression. So that's how the we just finalize this problem. Now we will solve a problem which is based on the empirical formula for the discharge over the rectangular weir. So there is two popular empirical formula proposed by the Francis and Brazen. So based upon these formulas, we will figure out the how to estimate the discharge. So the problem says that head of the water over a rectangular weir is 50 centimeter, and the length of the crest of the weir with end contraction suppressed is 2.0 meter. So find the discharge using the following formula, Francis one as well as the Brazen's formula. So let's start the solution part. So the given values are this, the head over this is that is your h is equal to 0.5 meter, and the length of the crest of weir with in contraction surface is 2 meters. So L value is 2.0 meter. So the if we use the Francis formula, in order to get the discharge over the weir. So the Francis formula says that Q is equal to 1.84 times of L into H raised to the power 3 by 2. So this Q will be 1.84 multiplied by L is 2 and H is 0.5 raised to the power 3 by 2. So if we solve this equation, we will get that Q is equal to 1.30 meter per second. And in the next section, we will solve the same problem using the Brezhnev formula. So Bayesian formula is somewhat much different, where the involvement of H is more. So the Bayesian formula says that Q is equal to M into L into under root 2G H raised to the power 3 by 2. So M is a different constant that is depending upon H itself. So this is 0.405 plus 0.003 over H. So first of all, we will determine the M value. So this will be 0.405 plus 0.003 divided by H value is 0.5. So M will come out to be 0.411. So this is the M value. Now we will figure out this Q value. So Q is equal to 0.411 into L is 2 meter, and then under root 2 multiplied by 9.81 multiplied by 0.5 raised to the power 3 by 2. So Q will come out to be 1.287 meter cube per second. So this is the answer we are getting from the Bayesian formula, and this is the answer we are getting from the Francis formula. So these are very close. However, this M value is dependent upon the head. So that's why this formula is somewhat much different from the Francis formula. So this particular demonstration shows that how to approach for the estimation of the discharge over the rectangular weir. So that's how we used for the in the field. So our next problem is such that where we do have a very long weir, and that is being divided into number of the base, and using this by using this base we do have subdivided weirs, and using the subdivided weir, how the discharge over the weir has to be determined, that we will solve for this problem. So the problem says that a 45-meter long weir is divided into 15 equal bays by vertical post, and each is 30 centimeter wide. So determine discharge over the weir if the head over the crest is 1.5 meter and the velocity of approach is 2 meter. So let's go for the solution of this problem. So first of all, we will list all the values which is given. So length of the weir, that is we can say that is L1 we can say. So L1 is given us, that is a 45 meter, and the number of bays is 15. For 15 number of bays we need the 11 post. That we can understand that if we have a VS as that, and if this channel is some posts are over there. So let's say there are 3 posts. So the inclusion of 3 posts has divided the weir into the 4 sections. So using the same strategy, now we know that with having a number of 15 bays, the required number of posts is 14. 15 minus 1. So this will be the number of vertical posts. So width of each post will be can be determined. So that will be equal to the uh, as the width of the each post is already given in this problem, that is the 30 centimeter. So this is 0.3 meter. Then the effective length of the weir, we can find out that effective length, that is our L, that will be equal to L1 minus a number of posts are, let's say this is n value, and multiplied by the width of the each post. So let's say this is W. So effective length L will come out to be, L1 is 45 meter minus n is 14, and the width W of the each post, let's say this is W, so this will be 0.3. So this comes out to be 14 multiplied by 0.3 is equal to 40.8 meter. Now the head over the crest is already given. So that is our h. That value is I guess 1.5 meter. So 1.5 meter. Now so velocity of approach is also given to us, that is 2 meter per second. So VA value is 2 meter per second. Now having all this such value, we can determine the HA. So HA is equal to VA square divided by 2G. So this value comes out to be 0.2038 meter. Now, so number of end contractions are, so the number of end contractions will be the 2 multiplied by the number of bays which has been divided, is that is 15. So the end contractions will, number of end contraction will be 30 here. Now we will use the formula, that is Francis formula for end contraction and the velocity of approach. So the using the Francis formula for this estimation of Q, that says that Q is equal to 1.84 multiplied by L minus 0.1 multiplied by N multiplied by H plus HA, and then again in bracket H plus HA raised to the power 3 by 2 minus HA raised to the power 3 by 2. So let's put all the values. So Q will be 1.84 in bracket. L value is given to us, that is 40.8 minus 0.1. Now N number of end contractions are that is 30. This is 30, and the H is given to us. H is 1.5 meter. So 1.5 plus HA is 0.2038, and then bracket close, and then so 1.5 plus 0.2038 raised to the power 3 by 2 minus 2038 raised to the power, this 3 by 2, and then bracket closed. So once we solve this Q value, so this will give the answer of, so calculation gives that Q is equal to 139.92 meter cube per second. This is the our answer. So our next problem is also where the weir with end contractions are available there, is there. So it is interesting to note over there that instead of figuring out the discharge, this problem asks for the possible number of the openings with given the discharge value. So let's go for the solution of this problem. So problem says that a discharge of 5000 cubic meter is pass over a rectangular weir, the weir is divided into a number of openings and each of a span of 10 meter. If the velocity of approach is 5 meter per second, find the number of the openings needed in order to head of the water over the crest is not exceeded by the 3 meter. So the Q value is given to us. So Q is 5000 cubic meter per second. Now, so number of length of the each opening 10 meter. So we can say the length of each opening. Length of each opening at L is 10 meter, and the next that VA value is given to us, that is 5 meter per second, and the head over the weir that is required over here is 3 meter, so that should not exceed by the 3 meter. So H is required is 3 meter. Now everything is given to us. With this values we can go for the solution of this problem. So we have to figure out the number of openings. So let's say that number of opening is n. Number of opening is n. So using this particular approach, we will figure out what is the HA value. HA value is V square divided by 2G, and this will give us the 5 square divided by 2 multiplied by 9.81, and this will give the answer of 1.27 meter. Now there is an important point that for each opening the number of end contractions are 2. So for this problem, the discharge for each opening considering the velocity of approach can be given by the Francis formula. So Q is equal to 1.84 multiplied by, in brackets, L minus 0.1 multiplied by 2 in brackets H plus HA, and then over H plus HA raised to the power 3 by 2 minus HA raised to the power 3 by 2. That particular formula is used for the estimation of the discharge. So we can put all the values. So Q is equal to 1.84. L is our 10 meter. 10 minus 0.1 multiplied by 2, so this is 0.2, and H is given to us is 3 plus HA is, we find out 1.27 bracket close, then this is 3 plus 1.27 raised to the power 3 by 2 minus 1.27 raised to the power 3 by 2. So if we solve this thing, the answer will be coming out to be Q is equal to 124.4 meter cube per second. So that is the discharge we are getting from each opening considering the velocity of approach. Now in order to get the number of opening, the total discharge, it is already given to us, that is the 5000, and this discharge is coming from the each opening. So so in order to get the number of openings, that is the n, we have to do the total discharge and then the discharge which is obtained from the each opening. So this value will be coming out to be, total discharge is our 5000 divided by 124.4. So the answer will be 5000 divided by this is nearly, the answer is coming out to be 40.2. So we can say that this is nearly the 40 number of openings is there. So number of opening is 40. So this is our answer. Next problem we are considering is related with the superlative weir. So the question says that a superlative weir of the crest length of 0.8 meter discharges the water. The head of the water over the weir is 0.4 meter. Find the discharge over the weir if the channel is 0.95 meter wide and 0.65 meter deep. So let's start for the solution of this particular problem. So first of all, we will write down all the values which is given to us. So the CD value is already given, that 0.6, and length of the weir that is given to us is 0.8 meter. So L is length of the weir, that is 0.8 meter, and then head of the weir, so H value is 0.4 meter. Now, the channel depth is also given us, which is 0.6 meter. So channel dimensions such that the channel width and depth of flow. So depth is 0.6 meter and channel width is 0.95. Please excuse me, this is not 0.95 centimeter, this is 0.95 meter. Now, so if we solve this problem, so the area of cross section of the channel, that is A, can be written as 0.95 multiplied by 0.6. So that's come out to be 0.57 meter square. Now, so the velocity of approach will determine the discharge over the weir. So Q value will be for this particular weir is 2 by 3 CD multiplied by L multiplied by under root 2G H raised to the power 3 by 2. So if we put all the values, we will get the Q value. So Q value is coming out to be 2 by 3, CD is 0.6, L is given to us, so L is 0.8 and multiplied by under root 2, 9.81 multiplied by H raised to the power 3 by 2, so H is 0.4 and raised to the power 3 by 2. So if we simplify, this Q value will be 0.360 meter cube per second. That is the Q value. Now using this Q value, we can figure out the VA. So VA is equal to Q over A. So Q is 0.360 and A is 0.57. So this gives a value of 0.63 meter per second. Corresponding to this HA, we can figure out, so this VA value, HA, we can figure out that VA square divided by 2G. So this value is coming out to be 0.020 meter. So that is the HA. So now using the discharge equation, what we can write that Q is equal to with inclusion of approach velocity 2 by 3 multiplied by the CD multiplied by L under root 2G H plus HA raised to the power 3 by 2 minus HA raised to the power 3 by 2 and then bracket close. So let's put all the values, and after putting all the values, we can get Q value as, the Q value comes out to be 0.3841 meter cube per second. So that is our answer. A broad crested weir of 60 meter length has a 60 centimeter height of water over its crest. Find the maximum discharge. Take CT value is equal to 0.6. So first is the neglect velocity of approach. I mean, first part is without the inclusion of the velocity of approach. So A should be there, that is missing over there. So this is the A part, and B part is if the velocity of approach is to be taken into the consideration, find the maximum discharge when the channel has a cross sectional area of 60 square meter on the upstream side. So let's go for the solution. So first of all, we'll note down all the values which is given to us. So the length of the weir, that is L, is 60 meter and has a height of head is your h is 60 centimeter, that is 0.6 meter. So next is the CD value is given as 0.6. So neglecting the velocity of approach, if we figure out the q value, then we can write that q is equal to for broadcasted weir is 1.705 multiplied by CD multiplied by L multiplied by H raised to the power 3 by 2. So if we put all the values, 1.705, 0.6, L is 60 meter multiplied by 0.6 raised to the power 3 by 2. So answer will be 28.52 meter cube per second. So that's the first part. Let's go for the second part. So this was part A. Now we will go for the part B, that is B. So where the velocity of approach will be considered. Now so for this thing, we have to use the formula again. This is the corresponding to the q max. So same formula is there, only the VA is involved. So when the velocity of approach is there, so Q max for the broadcaster weir, the formula can be written as 1.705 multiplied by CD multiplied by L, and in brackets this is H plus HA raised to the power 3 by 2 minus HA raised to the power 3 by 2. Now, first of all, we have to figure out the value of HA, and HA will be find out by the VA. So in order to get the VA, this VA can be Q by A. So Q is given to us, that is the from the previous Q value. So this Q value is 28.52. Now divided by the area. Area of this is your channel is 60 square meters, so that is 60. So this will give us a VA value of 0.475 meter per second. Corresponding to this, HA value will be VA square divided by 2G. So it's a square. So HA is coming out to be 0.0115 meter. Now we will put these values of HA and all, then we'll get the Q max. So Q max is equal to 1.705 multiplied by 0.6. L is your 60, and then H is given to us that H is 0.6. So this is the 0.6 plus 0.0115 raised to the power 3 by 2 minus 0.0115 raised to the power 3 by 2. That will give us the value of Q max. So Q max will be equal to coming out to be 30.5 meter cube per second. So that is the Q max when the VA is considered. So you can see the difference between these two things. So when VA is approached, the value of Q max is 30.5. However, without the consideration of VA, this value was 28.52. Now we will take a problem on the submerged weir. So the problem says that the height of the water on the upstream and downstream side of a submerged weir of 3 meter length are 20 centimeter and 10 centimeter respectively, and coefficient of discharge for the free and drawn portions are 0.6 and 0.8 respectively. So we need to find out the discharge over the weir. So let's go for the solution of this problem. So here we need to take care of that CD value for the free as well as the drawn portion are different. So that's why we will use this discharge equation into the two section. So for such kind of problem, first of all we'll figure out what the values are given to us. So the height of water on the upstream side is given to us, h is equal to 20 centimeter. So this h is equal to 0.2 meter, and height of the water on the downstream side. So this is the upstream side, and similarly height of the water on the downstream side can be written as small h, that is 10 centimeter. So this is 0.1 meter. And now the length of the weir is given to us, that L is equal to 3 meter, and we have to take the CD1 and CD2 because two coefficient of discharge are over there, so that is 0.6 and 0.8. Now if we will write down the formula for the discharge, so discharge over the drowned weir will be in the counted into the two portions. So this is the summation of the discharge through the free portion and discharge through the drawn portions. So the discharge over the free portion plus discharge over the drawn portion. So for both these segments, we have to write down the equation. So let's say this is the total discharge is Q. So Q can be written as 2 by 3. So first portion we are saying that CD1 and multiplied by L multiplied by under root 2G and H minus H raised to the power 3 by 2 plus 2 by 3 CD2, and then L multiplied by H multiplied by 2G H minus H. If we now replace all the values, so this will be 2 by 3, CD1 is 0.6, L is your 3, and then under root 2 multiplied by 9.81 and multiplied by this is 0.2 minus 0.1 and raised to the power 3 by 2 plus I just made a mistake. This value will not be the 2 by 3. So CD2 will be the is given the 0.8, and then L is 3 meter, and then again H, so small h is 0.1 and multiplied by the 2 multiplied by 9.81, and then capital H is 0.2 minus small h is 0.1. So if we solve this problem, the total discharge is coming out to be 0.504 cubic meter per second. So this is the our answer for using the drowned weir. So this is the first portion. If you can see, this is the first portion and this is the free portion, and second portion discharge is for the drowned weir portion, that we have to calculate this separately. And if the CD1 and CD2 are the same, we have to use, if only one discharge value is given to us, then we will use the uniform CD. Otherwise we have to also take care that the coefficient of discharge are different, then we will use the different value. So this is our answer, and that's how all the problem related with this chapter is concluded over here.